So I want you to take your colored paper and put it on top of the paper I just gave you. Okay? And then I want you to punch holes. Oh, excuse me. I want you to staple on either side of the holes. Does that make sense? Staple on either side of the holes. Here you go. Now, for those of you who chose a darker color, you know that's fine. You might want to have a pen or a darker color to write with on the top of that paper. Okay? So if you chose like a red or an orange or a dark blue or a purple, you're going to want a pen or like a marker to write on top of that paper. Okay? Everybody okay so far? Alright, those of you who have your staples done, what I want you to do now is fold the colored paper back and crease it. Okay? See where my fold is compared to where my holes are? That's not as important. I just don't want you to fold it like all the way back so the fold is on the holes. Does that make sense? I want you to have a little space right here. Okay, are we all stapled and are we all folded? We're ready to go? Okay, so open it for just a minute. I want you to notice two big things on here. There's the top one that says standard equation of the parabola with the vertex at the origin, and then there's this one right here that says standard equation with the parabola of a parabola with the vertex at HK. Okay? Now I wouldn't have highlighted those two. If you have a highlighter, you can use it. If you all you have is a pencil, you might want to put a star beside them so you can know that those are important for you to know. Or if you just have a colored pencil or something and want to circle it or something like that. I don't want to squelch your creativity right here. But knowing where those two are really going to help, because our next step is we need to make some cuts. Okay? So I'm going to turn mine this way again. What I need to do is I need to cut my colored paper only. I'm going to say that again. I need to cut my colored paper only. And because it's really important, I'm going to say it one more time. I need to cut my colored paper only. Okay? But I need to cut it so it's right above this highlight one. Okay? So I need to cut it right here for mine. But I'm only going to cut it to my fold. Does everybody understand that? See where I cut? I only cut to the fold. So that when I open it, all I can see is the stuff below. Or all I can see is the stuff above. Does that make sense? If you need help, please let me know. I'll be happy to help. Remember, you're only cutting the colored paper. I should have said that. Just teasing. Okay, so everybody made their first cut. Now, when you open just the top section, I'm going to zoom in just a little bit so you can see. When I open the top section, do you see that there's this section right here and this section right here? There's a vertical axis of symmetry section and a horizontal axis of symmetry section. Do you see that? So now I need to turn it sideways again because my next cut needs to be between those two. My next cut needs to be right here. the colored paper. Am I expecting this to be perfect? Am I expecting it to be close to perfect? No. I just want you to do your best, right? But now I can only see that top part or that part right there. Okay? Looks like you're all doing okay. Do you have any questions? Do I need to help? Can I help? You're okay? Thank you for helping each other. I appreciate that as well. Okay? Now, if it's not perfect, should we cry? No? But if you do, I do have tissues on my desk if you need them. Okay? Now, the same thing that we did in the top section, we're going to do in the bottom section. Okay? So again, noticing that it says vertical axis of symmetry right here and horizontal axis of symmetry right here. I'm going to make a cut on my colored paper in between, like right above where it says horizontal axis of symmetry. Okay? So you should have 4 flaps. 4 flaps of colored paper covering your white piece of paper. Yes? Everybody good? Now, because if I just take this out of my bag or off my desk and want to use it, I don't remember what's under what flap, right? So let's make some notes on the front of each flap so that we know what's going on underneath that specific flap. Okay, so the very top flap, this one right up here, we're going to write vertical axis of symmetry. For the visual learners, we're going to make sure we draw graphs so we know what that looks like. And then we're going to remind ourselves also that this has a vertex at the origin. Just little hints on the top of what's happening underneath. Okay? So the second tab says horizontal axis of symmetry. With a vertex at the origin. Or vortex, I don't know what you want to say. Everybody got that okay? Do you have the top tab? Okay, I'm going to slide it up then and write on the third tab. Well, I'm going to wait actually. I don't want to lose anyone. We good so far? Yes? Okay, now, what's under this tab right here? Vertical axis of symmetry again? But I already have one of those up there. So how are these two different? Vertex is not at the origin, right? Okay, so vertical axis of symmetry. But this time when we draw our graphs, we have to make sure that our vertex is not at the origin, right? It could be right there. It could be right here. It still has a vertical axis of symmetry, so it needs to open either up or down. But this time our vertex is at HK. Where's our vertex if it's at the origin? What's HK? 0, 0, right? Okay. This is going to be something else besides 2 zeros. Although, couldn't I just as easily put in a 0 here and a 0 here? Yes, right? You'll see why we have two separate formulas for it in a second. Okay? At least I hope you will. What's the bottom one going to say? Good. When I draw my graphs, I'm making sure that my vertex is not at the origin, right? Because my vertex is at HK. Okay, do you have all your labels written now on the fronts? Almost? Okay. Is that everyone? Yes? Okay. So let me walk you through this for a second. Okay? I want to go to the very first tab, very top tab. Okay? I've already taught you 3 equations this week. Why would I teach you another one? It depends on which one, what information you're given, right? If I started talking to you about a directrix and a focus, do you have any idea what that is? No, but that's the information that you're given a lot. Or sometimes, I guess I should say. Okay? And so you have to have all the information you need in order to be able to write the equation. Depending on what information you're given will depend on where you start. If you're given the y-intercepts, or excuse me, the x-intercepts, do you care about this? No, we already have an equation that we learned on our foldable from the other day of what to do with intercept form, right? If we have intercepts. If we're given standard form or vertex form, we already know how to use that. But none of those help if I'm given a focus or a directrix, right? Some of you even think I'm making up words right now, right? Because you've never heard those words before. Maybe you've heard focus, not in this situation, but you know what the word focus means, right? Okay, I think I've even said it to you before. Let's focus, right? Different meaning for this, all right? But it depends on what information you're given. And if you're given information like the focus or directrix, this is the equation you need, okay? So, I want to back up just a little bit. Why in the world did I not just give you this paper? Just like this. Oh, very much so, right? You have a tendency to be completely overwhelmed by this information, right? This much information at one time. So what we did is help our brain not panic. Ooh. Okay? What we did was help our brain not panic. We can look at little bits of information at a time. Okay? That's a strategy you can use in other people's classes too. It's not just in my class. Okay? So here's the deal. We need to talk about what these words even mean. Focus and directrix. Okay? Now I want you to know, I know it's probably a little too much, but I'm going to open this tab real quick. So I want you to see where in relation the focus is to the parabola itself. If the parabola was a Pac-Man, what is the Pac-Man doing to the focus? Eating it. Always the focus is going to be inside the parabola. Okay? Hopefully that will help you remember. If not, I'll say it again or say it a different way. Right? Where's the directrix in relation to the parabola? It's outside of it, right? It's away from it. The parabola is not ever going to eat the directrix. The directrix is like behind the parabola, if you think about it that way. Does that make sense? Okay, now I want you to notice that the focus is a point. The focus is a point. The directrix is a line. Okay? Now here's the deal about a focus and directrix. When we're talking about parabolas like this, any point that I choose on the parabola, if I measure the distance from that point to the focus and the distance from that point to the directrix, those distances are equal. If I choose this point right here, that distance and that distance are equal. When you're given a focus and directrix, that's how a parabola is created. It's all of the points that are equidistant from a focus and a directrix. Does that make sense? Okay, so there's a distance called P. Okay? The distance from the vertex to the focus is P. The distance from the vertex to the directrix is also P. Well, that would already make sense if you know those distances are all the same, right? Okay? So I'm going to give you all sorts of different combinations of, I might tell you the focus and the directrix. I might tell you the vertex and the directrix. I might tell you the directrix and the focus. I'll give you all sorts of combinations, and because you know those things of information, you're going to be able to tell me the equation. I'm going to give you the equation and ask for the focus, or the vertex, or the directrix. And because of what's written in the equation, you'll be able to tell me all that. Okay? Now, the question I got asked earlier is, where's the 4 come from? Any ideas? First of all, is it always a 4? It's always a 4. Okay? We don't have to care. We just don't. We have to care enough to know that it is in the formula, and if I know P, in order to figure out the denominator of this fraction, I have to multiply it by 4. Does that make sense? Okay. Now, the only thing different here, here's the difference. This vertex and this focus, that distance is P, right? And that distance is P. But when I put the number into the equation, what has to be true about the number? It has to be negative, right? Now, I know I'm saying P is a distance, and we normally don't talk about a distance being negative. But when I put P into the equation and it's a negative, I'm not really talking about the distance anymore. I'm talking about a direction. Okay? This direction is opening up, so that P value is positive. This distance, or this parabola is opening down, so that P value has to be negative. Does that make sense? Same kind of thing on horizontal axis of symmetry parabolas. This one's opening to the right, so that P value is positive. This one's opening to the left, so that P value has to be negative. Does that make sense? Okay. Now, notice real quick, I'm going to open these top 2 tabs so we can see a couple things and compare. Okay. This equation of the one you're used to, opening up or down, like the functional parabola, y equals x squared. Y equals x squared. Both of these are y equals x squared. This one's going to be a positive number. That's going to be a negative number, right? Look at this one. X equals y squared. When it's y squared, which direction is it opening? Right or left. Okay, do you see the difference? So, I want us to look at this one. If I can focus or move the camera real quick, I want to look at these two. Because both of these two have a vertical axis of symmetry. Well, why wouldn't I just use one equation? Because if my vertex is at the origin, couldn't I just as easily put in a 0 here and a 0 here? I could, right? And so sometimes I even myself question, well, why wouldn't I just give them these bottom 2 equations to use? Because that seems like it would be less confusing, right? Well, which one looks less confusing, this one or this one? The top one looks way less confusing, right? And if you already know that's at the origin, just go straight here and not have to worry about HK. But if worse comes to worse, can you use this one every time for a parabola that opens up or down? Yes, regardless of where the origin is, or the vertex is. Does that make sense? Okay. Now, there's all these formulas right here for focus and for directrix, focus and directrix, all the way down, right? Am I making you memorize those formulas? Absolutely not. That's why we have this foldable, right? And technically it is a foldable because how many times did we fold the paper? 1 time, right? We cut it several times. We made a fold right here at the beginning, right? This fold right here. So technically it's a foldable. In order for you to be able to use it on your quiz or test, what needs to be there? Is it there? If it's not, can you please put it there real quick? Okay, name on the back. Oh my goodness. It's a vertex, honey. Vertex. That's not a vortex.
No, we like the energy. There's an energy called vortex.
All right, so let's do some examples so you know what can be done with this kind of information, what kind of equations can be written. Okay? So I've got a piece of paper here and I've got my foldable. I'll just be moving it back and forth so we can see what's going on. Okay? So the first thing I'm going to ask is I need you to write some equations. Write the equation. Yes, please. So first of all, I'm going to tell you the directrix is at y equals 7. And the focus is at 0, -7. Well, you guys know how much of a visual person I am, right? So I'm going to draw myself a little graph over here. Not worried about it, whether it's to scale or not. If it crosses the y-axis at 7, it's like right there, right? That's my directrix. Y equals 7. My focus is at 0, -7. So down there, that's my focus, right? So the first thing I need you to be able to tell me is where's the vertex? It is. How do you know it's at the origin? So it's halfway in between the directrix and the focus, isn't it? And if that's 7 up and that's 7 down, guess where the vertex is? Right there, right? Now, can you tell me whether it opens or which direction it opens?
Yeah.
How do you know it opens down?
Because it's always eating the...
It's always eating the focus, right? It's having a focus snack. Oh, that's an ugly parabola. Please don't judge my parabola today. Okay? Well, if it's opening down, I'm using this section of the very top section of my foldable, right? So I need to start with y equals 1 over 4 times p. What's p in this problem? P is the distance from the vertex to the focus or the vertex to the directrix. 7. But which way did you say was opening? So I need to have that directional negative in there, right? X squared. Can that be simplified? To what? Y equals -1 over 28 x squared. That's my equation. Got it? Okay? Like, okay, ready to go on to the next example, or we need to talk about this one still? Ready? Okay. All right. What about the next example? What if it says the vertex is at the origin and the focus is at 10, 0? Well, what am I going to do first? I'm going to draw it, right? Do you have to? No. Some of you can do this in your head, and if you can, that's great. I am approaching it for the people that can't do it in their head. Is that okay? So there's my vertex. Where's my focus? 10 to the right, right? 10, 0. So there's my focus. So which direction does this open? To the right this time, okay? So like that, except it actually goes through the vertex. Pretend it goes through the vertex, please. So this time I'm doing the second tab, right? Oh, what's my other foldable? Sorry. Second tab. This time it's x equals 1 over 4 times p. What's p in this problem? 10. Is it a positive 10 or negative 10? Because it opens to the right. So y squared, right? Because x equals 1 over 4py squared.
So if we simplify that as 40,
X over 1 over 40 y squared. That's it. Do they get more difficult?
Yes.
Oh, yeah. All right. I just wanted to start you off easy, right? Vertex 1, 2, directrix, x equals 5. 1, 2, 1, 2, 3, 4, 5. It's crossing the x-axis at 5. That's my directrix, isn't it? X equals 5. And that's my vertex. Which way does this open?
It opens to the left.
It definitely
It's on
opens
that
to the
side.
left, doesn't it? If my directrix is over here and there's my focus or my vertex, it has to open away from the directrix, doesn't it? Okay? So if it's opening away from the directrix, it's going this way. Now, I need to make sure you know how to find the focus. Could you tell me where the focus was? If I asked for it right now, could you tell me where the focus was? So 1, 2, 3, 4, right? That P is going to be 4, right? So if the directrix is this way 4, where's the focus? 1, 2, 3, 4. It's that way 4, isn't it? Isn't that the focus? So it's really, the focus is really -3, 2, isn't it? Because I went 1, 2, 3, and then up 2 to be on the same level as this. Do you see how sometimes this might be confusing if I'm trying to graph it on my own? Are you allowed to go get a piece of graph paper to use for your homework tonight if you want that? Absolutely. You know where it is. You just go pick one up on your way out. Does everybody understand that? Okay. But is this required? No, some people can do this in their head, and if you can, that's fine. Okay? All right, so which tab am I using then? The very bottom one? Very bottom one. Okay. So I have x equals 1 over 4p y minus k squared plus h. Oh, geez Louise. Do I know what p is? Yeah, I figured it out before. It's 4, except it's opening to the left, so what am I putting in for p? -4. What about h and k? That's the other thing I need to know. Isn't that h and k right there? Isn't the vertex h and k? Like, that's what we even called it, right? The vertex is at hk. So now fill in what we know. X equals 1 over 4 times -4 y minus 2 squared plus 1. Now we can simplify that a little bit, right? X equals -1 over 16 y minus 2 squared plus 1. How do you feel about this? Okay-ish? I can work with okay-ish. That's fine. Okay? So what if we started right here? What if this is where I started you? And I said,
Well, you know the vertex.
oh yeah, but I mean, you say that lightly like it's super easy, but some people struggle with that. So if you can see the vertex, good, right? Good. What is the vertex? Even if I covered that up, what's the vertex? How would you know?
Because the H and
H and the K. Now, sometimes people get tripped up about remembering which one of these is H and which one of them's K, right? Which one is which?
Well, the last one's
This is the Y, right? And which variable goes with the Y value? The K. So some people always think, well, the first one's H, the last one's K. Don't get tripped up by that. If what's in the parentheses is the Y, then that is the K. And that other one is the H. What if this wasn't here? What's the H? 0. Okay? If it's like this, where's the vertex? Well, that's super simple, right? Because there's no H and K at all, so you know that it's at 0, 0. Does that make sense? Okay? What if I told you something like the parabola opens down, and the vertex is at 2, 6. Oh, I need another piece of paper to write that on, right? Let's say it opens down. The vertex is at 2, 6. Is that enough information to tell me anything else? No, right? It's not enough. Only one piece of information doesn't help. I mean, I know it opens down. I know if it opens down, we're using the y equals one, right? If it opens up or down, isn't it always y equals? Right? So y